Our planet is a world defined by water. Oceans cover over 70% of its surface, yet we have only explored a mere 5% of these watery realms. The deep sea, once thought barren, is teeming with life. Technological advancements reveal a world as diverse as any on land. Exploring the ocean is about understanding our planet and our place within it. Descending from the sunlit surface, we enter the twilight zone, a realm of fading light and perpetual darkness. Here, life has adapted to survive in a world of perpetual twilight. Bioluminescence is a striking adaptation, allowing organisms to produce their own light. This glow serves various purposes, from attracting prey to deterring predators. The giant squid with its massive eyes detects the faintest light. The twilight zone showcases the adaptability and resilience of life. As we explore, we uncover more wonders, illuminating the hidden tapestry of life. Venturing deeper into the ocean's embrace, we plunge into the abyssal zone, a realm of perpetual darkness and crushing pressure. Here, sunlight never penetrates, and the weight of the water above is equivalent to having several elephants standing on a postage stamp. Yet, even in this seemingly inhospitable environment, life finds a way. The creatures that inhabit the abyss have evolved unique adaptations to survive the extreme conditions. Their bodies are often gelatinous and lack hard parts, allowing them to withstand the immense pressure. Many are blind, relying on other senses, such as vibrations and chemical cues, to navigate and find food. One of the most important sources of food in the abyss is marine snow, a continuous rain of organic matter from the surface waters. This detritus, consisting of dead plankton, fecal pellets, and other organic debris, provides sustenance for a variety of organisms, from tiny crustaceans to giant isopods. These scavengers in turn become prey for larger predators such as anglerfish, viperfish, and deep-sea dragonfish. The abyss is also home to a variety of invertebrates, including sponges, corals, and sea stars. These creatures often grow slowly and live for a long time, some for centuries. For example, deep-sea corals, which can form massive reefs, provide habitat for a variety of other organisms, creating oases of life in the vast abyssal plains. Life in the abyss may be strange and unfamiliar, but it is a testament to the ingenuity and resilience of life. In the face of extreme pressure, perpetual darkness, and scarce resources, organisms have evolved extraordinary adaptations to not only survive, but thrive. In the depths of the ocean, where sunlight cannot reach, a remarkable phenomenon occurs. Life thrives not on photosynthesis, but on chemosynthesis. Hydrothermal vents, fissures in the ocean floor where superheated, mineral-rich water spews forth, are oases of life in the otherwise barren abyssal plains. These vents, discovered in 1977, revolutionized our understanding of life on Earth. They demonstrated that life could exist in the absence of sunlight, relying instead on the energy released from chemical reactions. This process, known as chemosynthesis, forms the basis of a unique and thriving ecosystem. Bacteria, the primary producers in these ecosystems, harness the energy from hydrogen sulfide and other chemicals spewing from the vents to create organic compounds. These bacteria in turn support a diverse community of organisms, including giant tube worms, clams, mussels, and shrimp. Giant tube worms, which can grow to over 6 feet in length, have no mouth or digestive system. Instead, they rely on symbiotic bacteria living within their tissues to provide them with food. Hydrothermal vents are not the only places where chemosynthesis occurs. Cold seeps, areas where methane and other hydrocarbons seep from the ocean floor, also support chemosynthetic ecosystems. Like hydrothermal vents, these seeps are home to unique and diverse communities of organisms. The discovery of chemosynthetic ecosystems has profound implications for our understanding of the origins of life on Earth and the potential for life on other planets. It has shown us that life is far more adaptable and resilient than we ever imagined, capable of thriving in the most extreme and unexpected environments. Section 5. Technological Marvels. Illuminating the Abyss. Exploring the deep sea, a realm of crushing pressure, perpetual darkness, and extreme temperatures presents formidable challenges. However, technological advancements in recent decades have provided us with the tools to venture deeper and explore further than ever before, illuminating the hidden wonders of the abyss. Submersibles, both manned and remotely operated, have revolutionized deep-sea exploration. These underwater vehicles, equipped with powerful lights, high-definition cameras, and robotic arms, allow scientists to observe and collect samples from the deep sea in unprecedented detail. Remotely operated vehicles, or ROVs, tethered to a surface ship, can remain submerged for extended periods, providing a continuous stream of data and imagery. Autonomous underwater vehicles, or AUVs, on the other hand, operate independently, following pre-programmed routes and collecting data without human intervention. These robotic explorers are particularly useful for mapping the seafloor, studying ocean currents, and monitoring marine life in remote and inaccessible areas. Advances in sonar technology have also greatly enhanced our ability to explore the deep sea. Multi-beam sonar systems mounted on ships emit sound waves that bounce off the seafloor, creating detailed three-dimensional maps. These maps reveal the topography of the ocean floor, including underwater mountains, canyons, and hydrothermal vents. The development of new imaging techniques, such as bioluminescence imaging, has allowed us to observe the behavior of deep-sea organisms in their natural habitat without disturbing them. These techniques rely on the light emitted by bioluminescent organisms to create stunning images of life in the deep. As technology continues to advance, we can expect even more sophisticated tools and techniques for exploring the deep sea. These advancements will undoubtedly lead to new discoveries, further expanding our understanding of the ocean and its inhabitants. Our oceans face numerous threats, from pollution to overfishing and climate change. These challenges are not just problems for marine life, they affect us all. The delicate balance of the ocean's ecosystem is under siege, and the time to act is now. Conservation isn't just an option, it's a necessity. Protecting our oceans means preserving the very foundation of life on Earth. We need to implement sustainable practices, create marine protected areas, and reduce our carbon footprint. Every small action counts toward a healthier ocean. The future of ocean exploration holds immense promise. Advances in technology are allowing us to explore deeper and more remote parts of the ocean than ever before. These discoveries can lead to new resources, medical breakthroughs, and a better understanding of our planet's history and climate. Now is the time to take action. Whether it's through supporting conservation efforts, reducing plastic use, or advocating for policy changes, everyone has a role to play. Our oceans are a treasure worth protecting, and together we can ensure they thrive for generations to come.